Hello everyone. Welcome to our course covering migration to AWS. Over the next 4 weeks, we'll be looking at topics around defining migration, analyzing your environment and needs, planning your migration, services that are commonly used during migration, and actual migration steps. During this course, I will be joined by Sean and Rick as we guide you through the topics, videos, and exercises. In addition to the videos, there will be notes for further reading and research, forums for various discussions you may want to present or participate in, exercises for some hands-on experience, and assessments to help reinforce some of the things we're talking about each week. We understand that this is going to be very high level and conceptual, but I hope that over the course of the next several weeks, you are able to better understand some of the things necessary when migrating to the AWS cloud. And I also hope you have a little fun along the way. That's all I have for now. Until the next video. To start off, this week we'll be discussing general migration concepts. We'll start with contextualizing what we mean when we say migration by providing some definitions to make sure we're all on the same page. After that, we'll look at the steps for migrating and then finish the week by covering what we call the 6 R's, which are various methods for migrating applications to the cloud. Your exercise this week will be to evaluate the steps of migrating an application to figure out what the proper way to approach based on the method chosen. Make sure you're looking at the course notes as you go through the week to gain additional information beyond what the videos are able to cover. That's it for now. You'll see me later.
Welcome to AWS Fundamentals, Migrating to the Cloud. We're your instructors.
Well, technically there's Rick too.
Oh yeah, where is Rick? Anyway, this is Sean. He's been at AWS for almost 4 years. He's a technical architect, and he loves triathlons and his dog Chief.
This is Seth. He's been at AWS for a little over 7 years.
7.5 years.
He's a cloud technologist.
Hey, don't laugh at my title.
Sorry. Anyway, Seth doesn't like any of the things that I do.
That's not true. I like puppies.
We do agree on puppies.
We look forward to spending the next few weeks with you talking about migrations.
We hope you learn lots of new and useful information. Still no Rick.
Oh well.
Where do we begin when starting down the path of migration? What do we mean by migration? In the context of this course, cloud migration is the process of moving data, applications, or other business elements to a cloud computing environment. Whether it is a server you want to retire, some data you want to move, or an entire networked environment that needs a new home, there are various types of cloud migrations an enterprise can perform. Seth and I will be covering the various types of migrations this week. All of these methods involve taking some portion of our environment and moving it to the cloud. Depending on the migration type you choose to perform, your migration will involve more or fewer AWS services. I typically like to start with identifying business drivers, since they tend to inform the technical decisions. Being able to answer the question of why should almost always come before answering the question of how. As we know, the cloud enables levels of agility that typically are not possible on premises. For many companies, the number one reason they choose to move to the cloud is the agility and speed that they can move with. The migration process involves 5 phases. Phase 1, migration preparation and business planning. Phase 2, portfolio discovery and planning. Phases 3 and 4, designing, migrating, and validating applications. And Phase 5, operate. In the next several videos, we'll take a look at each of these phases in more detail. Seth will begin by walking us through phase number 1.
When evaluating migrations to AWS, the patterns seen around migrating to the cloud commonly follow a 5-phase approach. The phases we outline in this regard are Phase 1, migration preparation and business planning. Phase 2, portfolio discovery and planning. Phases 3 and 4 are designing, migrating, and validating your applications. And Phase 5, operate. So let's start with Phase 1. When looking at migration through this context, planning and preparation will be where most of the time and effort are spent. While individual, non-crucial standalone systems may have the ability to be quickly moved over with little planning, it's because these provide minimal risk for impact should an issue occur. In most cases, the interconnectivity of the various components need more than just several hours of operational work. These types of migrations require very detailed and insightful planning and preparation for both the technical and business sides of the operation, which is why we start with migration preparation and business planning. Here is when the right objectives are determined and getting an idea of the types of benefits you will see begins. It starts with some foundational experience and developing a preliminary business case for a migration, which requires taking objectives into account along with the age and architecture of the existing applications and their constraints.
In Phase 2, we need to take a deeper look at our IT portfolio. The goal is to establish where our dependencies are between our applications and begin thinking about what types of migrations might work best for each. Not every application is likely to fall into the same migration strategy. This phase, with a focus on application discovery, is our best opportunity for building a clear use case and business case for each application. Depending on the age of your environment to be migrated, you may even identify applications that fit clearly into the retire strategy. The AWS Application Discovery Service can assist with this process by gathering information about your environment. We'll be taking a closer look at this service in Week 2.
Phase 1 involved planning and analysis. Phase 2 involved planning and analysis. Moving on to Phases 3 and 4 will still involve planning and analysis, but will also bring you into the times for action. With Phases 3 and 4, we are still planning with our designs, but we then migrate and validate. Here, the focus starts to shift from the portfolio level to the individual application level, where you're designing, migrating, and validating each application. Each application is designed, migrated, and validated according to one of the 6 common application strategies, or the 6 R's, which we will discuss later this week. From the previous phases, there are a couple of things I want to specifically point out. Well, one specific thing, and that is the need for each application to be designed, migrated, and validated according to what's necessary for those specific components. Just like with other areas of building and architecting, applications need to be looked at individually. Their needs require assessment, and then they need to be treated in the ways that best fit their use cases. This is not the time to try and force a one-size-fits-all type of mentality. I know this can sound like a lot, but once you have some foundational experience from migrating a few apps and plans in place that the organization can get behind, it becomes easier to accelerate the migration and achieve scale. Some more good news is that partners can help you here, as well as AWS Server Migration Service, AWS Database Migration Service, and Cloud Endure Migration.
So far, in Phases 1 through 4, we have discovered our applications, planned their migrations, and implemented those strategies. In Phase 5, Operate, we look at the ongoing operation of our applications and systems in the cloud and look to continue iterating. We've now created a new foundation that can be built on to further improve our operating environment. During the planning phases, you may have found applications that were good candidates for retirement, but due to dependencies, were unable to be removed from the environment. This is the phase that we begin to look at how to turn off some of these old systems. Phase 5 is an ongoing phase, taking all of the information and lessons learned from our migration and working towards continual improvement. There are many migration partners available to help you better operate in the cloud and become more proficient in your migrations. These companies have expertise in all phases of the migration process and can help with implementation, planning, or even training on migration technologies. In week 4, we'll take a closer look at the partner ecosystem and how they can help in your migration. Now that we've covered the 5 phases of migration, Seth and I will introduce you to the different migration strategies.
There are many tools and references that are available to you when evaluating needs for migration and cloud adoption, both from trusted third parties as well as from AWS directly. These will vary in focus and applicability, but can be very helpful if you find the ones that best fit the tasks you are trying to complete. One of these references that can be very helpful in the early stages of many migrations is the AWS Cloud Adoption Framework. AWS Professional Services created the Cloud Adoption Framework to help organizations design and travel an accelerated path to successful cloud adoption. The guidance and best practices provided by the framework help you build a comprehensive approach to cloud computing across your organization and throughout your IT lifecycle. The Cloud Adoption Framework covers what we see as 6 important perspectives to consider when looking at cloud adoption plans. The business perspectives look at business, people, and governance, while the technical perspectives focus on platform, security, and operations. The business perspective is there to help you move from separate strategies for business and IT to a business model that integrates IT strategy. The people perspective focuses on preparing teams for cloud adoption by updating staff skills and organizational processes to include cloud-based competencies. And governance is about the integration of IT governance and organizational governance. It provides guidance on identifying and implementing best practices for IT governance and on supporting business processes with technology. On the technical side, the platform perspective helps you design, implement, and optimize the architecture of AWS technology based on business goals and objectives by helping to provide strategic guidance for the design, principles, tools, and policies you use to define AWS infrastructure. The security perspective helps you to structure the selection and implementation of controls, and the operations perspective helps you to run, use, operate, and recover IT workloads to levels that meet the requirements of your business. The course notes will contain a link to our page on the Cloud Adoption Framework. I highly recommend that you dive into that page to familiarize yourself with the perspectives in order to make conversations and decisions about cloud adoption and migration as informed as possible.
What are we hoping to get out of the class over the next 4 weeks? Overall, in this class, we'll be taking a multi-tier application and migrating it to the cloud. A repeated focus over the next few weeks will be planning, preparing, and testing. As we make our way through the levels of our application stack, we will dive into how you might plan for the migration of that component, what AWS services could assist in both the preparation and implementation, and then look into how the strategy can be tested. Week 1 is all about laying the groundwork, covering the terms and concepts that we will dive into with the remainder of the class. Our goal in week 1 is for you to quickly get up to speed with familiarity of the migration phases and types. Week 2 is where planning begins. The main theme of any successful migration will have a strong emphasis on planning. This week, we will introduce you to our environment to be migrated and focus on the planning steps for migrating compute assets. This week also begins our introduction to AWS services that could be leveraged during a migration. Week 3 continues our focus on planning, moving to the storage and networking side of the discussion. We'll cover topics like databases and several of the more common AWS storage offerings that you might consider implementing in your migrations. Because many times our systems need to talk to each other as well as to the internet, we'll dive into networking at the end of the week. Week 4, we begin to automate. Where possible, your migration efforts should leverage scripting, tooling, or some form of automation to ensure repeatability, testability, and scalability. We'll introduce you to Cloud Endure, an AWS migration service, and show how it can automate many of the migration functions. By the end of our 4 weeks together, we'll have gone through a migration from start to finish and brought up the questions that you should have answers to before undertaking your own.
When beginning to discuss the how of migrating, it is important that you determine what is in your environment and the migration strategy for each application. Specifically for this purpose, we have 6 approaches that we see as common migration strategies for applications. The 6 strategies are rehost, replatform, repurchase, refactor, retire, and retain. You should gain a thorough understanding of which migration strategy will be best suited for certain portions of your portfolio. It is also important to consider that while one of these 6 strategies may be best for migrating certain applications, another strategy might work better for moving different applications in the same portfolio. Evaluate the needs of the specific applications, then find the approach or combination of approaches that will work best for each use case. Here, we'll start with rehost. We'll cover the other R's in subsequent videos. Rehost, commonly referred to as lift and shift, is a direct migration where you're trying to pick up and move your applications or environments directly into the cloud while trying to make as few changes as possible. This is also known as forklifting. While trying to migrate, it is common to want to optimize as soon as possible, but you may also find that applications are easier to re-architect once they are already running in the cloud. This happens partly because your organization will have developed better skills to do so, and partly because the hard part, migrating the application, data, and traffic, has already been accomplished. With rehosting, your goal is often just to try and get to the cloud as quickly as possible while maintaining the stability, functionality, and security of your existing system. Where rehosting was all about getting to the cloud quickly, replatforming is about gaining some optimizations while migrating. So instead of a lift and shift restriction, we're looking more at lift, tinker, and shift. Overall, this wouldn't look too different. You're still trying to maintain the stability and functionality, but you may also want to find some ways that will immediately make things easier in the long run. Maybe not major changes like going from a monolithic server environment to a service-oriented architecture, but something simpler to handle. Take, for example, your database. Databases vary in complexity and overhead to run, and this doesn't change when you move from running a DB server in your local environment to a DB engine running on an Amazon EC2 instance. What if you had a database that didn't require a lot of heavy customization? You were essentially just running it on a server containing a mildly optimized engine and your data. In this case, why not run the database in Amazon Relational Database Service, or RDS? This would not only enable you to maintain your database functionality, but you would also eliminate some of the management tasks while gaining features like high availability and automated maintenance actions. Times like this, when you're moving to a similar system that provides some additional benefits, can really help to optimize without a full re-architecting of your applications.
Other than the 2 migration strategies that Seth has already covered, rehost and replatform, we have 4 other migration strategies that you might determine are the best for one or more of your applications. They are repurchase, refactor or re-architect, retire, and retain. In the repurchase strategy, you're making the decision to move to a different product or licensing model. An example of this strategy could be to use the migration as an opportunity to upgrade to a newer version of a product, or maybe to move from a commercial license to an enterprise license, or vice versa. The important distinction is that you aren't fundamentally changing the design of the application or system. For the refactor or re-architect strategy, you are typically driven by a strong business need to add features, scale, or performance that would be difficult to achieve in the existing environment. Even though this strategy can sometimes be the most expensive when calculating hours spent, it can often yield the best results since it allows for taking full advantage of the benefits the cloud offers. If you're working in an environment with a lot of legacy applications or systems that have been around seemingly forever, the retire strategy can be implemented to help clean up and reduce the assets to be migrated. By removing the applications no longer in use, it allows you to direct your attention towards migrating and maintaining the resources that matter. The final strategy is to retain things as is. This decision can be made for a variety of reasons. Sometimes there are applications that you are just not ready to migrate. Or, in some cases, the business feels more comfortable keeping them on premises. If you've recently just gone through an application re-architecture or upgrade process, you might not be ready to prioritize making even more changes. As you make your way through your IT portfolio, each system and application should receive consideration in how its migration is going to be handled. There is no one-size-fits-all approach to migrations, so taking the time up front to plan will lead to the least headaches and most success.
While week 1 was about gaining an understanding of migration and looking at some of the methods, this week is focused on continued planning. For week 2, we're going to look at the importance of knowing our applications and infrastructure. Here, we'll evaluate some of the important areas to analyze within our portfolio, as well as some of the ways to discover the necessary components within our applications. As always, keep looking at those course notes and readings, and keep looking for how the topics covered will best apply to your specific use cases. So long for now.
One of the major motivations and benefits to migrating to the cloud is the scalability. Well, that's what I'll be talking about today.
What we'll be talking about today.
Sorry.
Okay. While scaling is a great and wonderful thing, there are some things that need to be considered. Depending on your application, there are all sorts of things that may change how you're scaling.
Some of the things we're going to look at today are scaling constraints, session data management, and major scaling methodologies.
Starting with constraints. This is important to cover because not everything can scale in the same way. If you have a limited number of licenses and getting more requires a lot of time, approval, or just a lot of processes to work through, dynamically scaling can be very difficult. Or perhaps your application just can't support the downtime it would take to change the underlying architecture so that it can handle more of a workload. In these cases, architecting in such a way so that you don't have to dynamically scale would be the way to go.
Looking at adding other components to help when you can't scale would be a good way to design around this. Resources like managed caches and queues help to not lose requests when scaling is limited. Also, offloading unnecessary work from unscalable servers could help. If you're working with a caching server and increasing its resources is going to be difficult, perhaps it would be easier if stale data was lifecycled off the server to conserve storage and not over-provision and overspend.
Strategies like these are just some of the ways you can work around these constraints.
But what if you have resources that technically can scale, but you don't want to lose session data in the process?
Well, since you so humbly asked, I'll tell you.
No need. I was just using you as a prop to lead me into the next section. So if your application has session data that you're trying to maintain, but also need to scale to adjust the changes in demand, the easiest thing to do is just store your session data off the instance.
Yeah, so as Sean was so helpful to point out, using off-server session storage can really help provide scaling in what could otherwise be a very constrained environment. Using data stores like caches can really help to maintain functionality while not limiting your scaling capabilities.
Thanks, Seth. I could have handled that on my own without issue, but thanks.
You're welcome. So, what was our last topic?
We were going to handle horizontal and vertical scaling.
Oh yeah, so let's do that.
I don't want to just talk about it though. What if we show it instead?
Sounds good to me. What did you have in mind?
Just follow my lead. So there are two different types of scaling, horizontal and vertical. Horizontal
scaling.
I said follow my lead.
Fine.
Horizontal scaling, or scaling out, is when we add more resources and distribute across them. The benefit of this is that it incurs no downtime for your original resource. As the load continues to grow,
we can continue to add more and more resources and spread the load across them. Once your load subsides and we need less resources, we can scale back into the original number. This is done with little to no impact to your end user. That's horizontal scaling.
I see what you're doing here. The other type of scaling is vertical scaling. With vertical scaling, you maintain the same logical resource, but you're making that resource more capable. Adding things like memory, storage, or compute power so that that resource can handle more of a workload. With this type of scaling, you don't have to distribute requests across multiple because you do still have that one same logical resource. But there are some limitations. One of those limitations is that there typically is some downtime when you are vertically scaling. The second limitation is that while you're scaling, you typically scale up, but I guess you don't scale back down. Uh-oh.
That covers our quick conversation on the two types of scaling. It's important to analyze your needs and plan your architecture and environment so that you don't incur any negative impact.
Do I really have to stay this big?
Bye.
Here we're going to talk about high availability. It won't take too long, I promise. The big thing I want to say about high availability is, drumroll please, create highly available workloads in AWS. That's it. That's all I had to say. Told you it was going to be short. Sorry, it's not going to be quite that short. I did want to give just a little more of a review. First off, what is high availability? It's building in such a way that allows for increased uptime or availability. Designing for the highest levels of availability is always a good practice, and moving into a cloud environment like AWS makes this easier than trying to achieve the same levels of availability in a traditional environment. From there, you'll just want to keep some things in mind as you move towards building and optimizing your migrated environments in AWS. A primary tenet here is to avoid single points of failure. If the failure of any single component or node would cause a negative impact to the system as a whole, look for ways to minimize the impact. In some cases, this could mean running more than one instance of a component, and in other situations, it could mean having a replacement that can easily be launched should the primary fail. Another way to help build towards higher availability is to utilize ways to distribute traffic and requests across multiple endpoints or nodes. Using load balancers is a major way this can be accomplished. Also, you'll want to have some scalability. In AWS, simply by using managed services, you achieve or can enable some fault tolerance just by how the services themselves scale. These services can provide a much easier path to high availability than if you were trying to just build it out manually. Other services enable individual resources to become scalable by either providing horizontal or vertical scaling. Look into all of these options to see what best fits your use cases. Lastly, something to consider when trying to add higher levels of availability is to monitor your environments. Monitoring can help you identify expected trends, trigger actions for anything outside of normal behavior, and help you to automate recovery of anything that might fail within your environment. This is incredibly important and cannot be stressed enough. Luckily for you, AWS has several services for both the monitoring and logging, any actions you might want to take, and events you may want to be notified of. Well, that wasn't too bad, was it? That's all I have for now. Please continue to look into how you can build and design for higher levels of availability within the systems that you bring to AWS. As has been mentioned several times now, when planning for your migration and evaluating the scope of what may need to be moved, it quickly starts to become clear that there is no single migration method for everything. depending on the type of application or component, the specific method used for its migration is very important. While we are not going to get into specific migration details here, one thing I wanted to bring up is the importance of decoupling the migration of your databases and data stores from your other applications and components. What makes this such an important topic is the fact that you're dealing with the incredibly important resource of data. The data needs to be secure, reliable, and have varying levels of accessibility. When migrating applications, much of the time and energy goes into ensuring consistent or maybe even improved performance. Planning and preparation is put into being ready when the switch finally happens, and there is rarely any middle phase to worry about between environments. With your data, because this is often one of the most crucial components of your application's environment, there may still be access requirements before, during, and after the migration. This is one of the reasons that database and data store migration is so important to consider and plan when handling the migration. Though we won't discuss the actual migration just yet, what I want to cover are some of the important planning and analysis steps. It is likely that many questions about your database will be well known before your migration is even a discussion. Things like the size, schema, types of tables, and engine-specific limitations are usually topics that are regularly discussed and reviewed. If you haven't done any other database updates or moves in a while, you'll likely need additional research when looking for information about access patterns and frequencies, connectivity methods, security, object sizes, and more. The questions continue to grow when you start considering any changes to the schema, infrastructure, or engine that might occur as part of the migration. This may seem like a lot, but understanding these things will greatly help when handling the migration and can save you a lot of time and headache down the line. Next, you'll want to understand your requirements. The requirements of your database for normal operation while migrating and in your new environment will all need to be analyzed. Are you replacing anything about the platform of your database? Do you know all the key parameters of your new environment? Can your app afford downtime, and how long can this downtime be? How much of the data needs to be migrated now versus later? These are just some of the questions that come to the surface when you start looking into the requirements. Part of this planning is also to understand your network. This is very straightforward. You will need to know the limitations of your network, how much of your bandwidth is available for you to use, how much of your network utilization can your database handle in both your source and destination locations. In some circumstances, this can be adjusted temporarily in order to facilitate a faster migration. But in other cases, you may have to figure out a way to work with what's already in place. Keep in mind that during the migration, you may be placing additional load on the database. How much of an additional load and for how long is going to depend on the migration methods. Another area to look into is planning your talent. Someone needs to know the source and destination database engines, which can be multiple people if any changes are being made. Somebody needs to know about servers, ports, and firewall rules, and how to handle the network requirements from a practical operations perspective as opposed to just theoretical. In many cases, this is too much for a single person to handle, so planning and gathering who is going to be involved becomes very important. The last item I want to cover for now is planning your time. Database migration projects often include refactoring of the application and database code, and also the schema. All of this is a time-consuming and iterative process. The refactoring process alone can take anywhere from a few weeks to several months, depending on the complexity of your application and database. If you have hard dates, be realistic about what you can achieve. Remember that even in the best of circumstances, migration might be slower than anticipated. These are just some of the areas for you to focus on when looking at how database migration differs from direct application migration. In the course notes, you will see more information and more details about how to prepare for your move. Until next time. If, like so many of you, you are already using virtualization in your current environment, and you want to maintain much of what you've already built in order to move it to AWS, this doesn't have to be something that you self-manage or build from scratch. AWS Server Migration Service, or SMS for short, is a tool available in AWS specifically meant to enable an easier transfer of your virtual resources directly into your AWS cloud environment. SMS is an agentless service which makes it easier and faster for you to migrate up to thousands of on-premise workloads to AWS. The service allows you to automate, schedule, and track incremental replications of live server volumes and makes it easier for you to coordinate small and large-scale server migrations. But before we go any further with the features of SMS, I do want to share some requirements that you need to be aware of when using the service. The main requirement is that AWS SMS is currently only available if you are migrating VMware vSphere, Microsoft Hyper-V, and Azure virtual machines into the AWS cloud. Keep an eye out for any updates to the supported source environments by checking the AWS Server Migration Service documentation. Another requirement for you to be aware of is that SMS replicates your server VMs as cloud-hosted Amazon machine images that can be deployed on EC2. This does not move VMs into functions or any other area of AWS, but it does allow for you to launch your server VMs as Amazon EC2 instances. The last requirement is that if you want to use SMS to help you transfer server VMs from your origin environment into AWS, you must use a connector. The Server Migration Connector is a free BSD VM that you install in your on-premise virtualization environment. The connector aids in the creation of appropriate permissions and network connections that allow SMS to execute tasks in your virtualized environments. Once setup has been completed, you are able to migrate up to 50 concurrent VM migrations per account. The SMS service talks with the Server Migration Connector in order to ease the task of migrating from the supported platforms. Testing is also simple to automate because the migrations create EC2 AMIs, which can easily be launched and tested for verification of successful migrations. Monitoring of your migrations is made possible by Amazon CloudWatch, and logging and auditing can be done through AWS CloudTrail. These are great to help with providing continuous visibility in your migrations and enabling you to set up events and alarms based on the log entry and metrics that you see, which then help you to automate actions based on the behavior you're seeing during your migrations. I know that was a bit quick of an introduction, but I highly suggest that you go deeper into SMS by diving through the documentation. Depending on your origin environment, there will be some differences with how you work with AWS SMS and how you manage the connector. That's all for now. I'll see you later.
Not all that long ago, planning for a migration also involved renting a moving van or contracting a moving company. There was the time spent unplugging all the cabling, pulling servers from racks, packing them up in boxes, loading up trucks, driving to new location, unloading boxes, putting servers into their new homes, and honestly, my favorite part, recabling everything. Then came everyone's favorite part, turning it all on and hoping everything worked, which rarely happened. Then the world started going virtual. We had fewer physical servers to manage, but a move or migration still looked an awful lot like before. After all, those virtual machines had to live on a physical server somewhere. At AWS, we like to say that we help remove the undifferentiated heavy lifting, allowing you to focus on what matters to your business. Well, in the case of migrations, that can literally mean heavy lifting. Have you ever tried to move a loaded storage area network appliance? Hard drives weigh a lot. Moving your VMs to the cloud will likely require lifting nothing more than a keyboard and mouse, or maybe your laptop. We have several services that can assist with the virtual heavy lifting, like VM Import-Export and the AWS Server Migration Service. VM import-export enables you to easily import virtual machine images from your existing environment to AWS as Amazon EC2 instances, or Amazon Machine Images, AMIs. This enables you to migrate applications and workloads to Amazon EC2, copy your VM image catalog to EC2, or create a repository of VM images for backup and disaster recovery. Once your applications and workloads have been imported, you can run multiple instances from the same image, and you can create snapshots to back up your data. For most VM import needs, we recommend that you use the AWS Server Migration Service, since it automates the import process. The AWS Server Migration Service, or SMS, automates the migration of your on-premises VMware, vSphere, Microsoft Hyper-V, and Azure virtual machines to the AWS cloud. Leveraging SMS to manage your server migration can add several benefits. It can simplify the process overall, requiring just a few clicks in the AWS Management Console once everything is set up. With VM import-export and AWS Server Migration Service at your side, the migration of your virtual machines to AWS couldn't be easier.
While we have had a good amount of discussion about planning your migrations and different tools that help in the migrating of your resources, one important area to bring up is the need to monitor your migrations. Migrating is not just something you can set and then forget. You need a way to identify what is happening, how well it's going, if everything is running as expected, and various other areas. This can all be especially difficult if you are using multiple tools across multiple AWS and partner solutions. AWS has a service called AWS Migration Hub. Using Migration Hub allows you to choose the AWS and partner migration tools that best fit your needs while providing visibility into the status of migrations across your portfolio of applications. This also provides the ability to see metrics and progress for individual applications regardless of the tools being used. This allows you to quickly get progress updates across all of your migrations, easily identify and troubleshoot any issues, and reduce the overall time and effort spent on your migration projects while providing a single place to monitor migrations in any AWS region where your migration tools are available. In order to view your assets in Migration Hub, you perform discovery using an AWS Discovery tool or by migrating with an integrated migration tool. Once you've performed discovery or started migrating, you can explore your environment from within Migration Hub. When the migration completes, Migration Hub also shows details about the resources that have been created by the migration. For servers migrated by AWS Server Migration Service, Cloud Indoor Migration, and other migration services and partners, Migration Hub provides links to the AMIs created or running Amazon EC2 instances. For databases migrated by AWS Database Migration Service, Migration Hub provides the target endpoint ID, which can be used as a search filter on the Database Migration Service Management Console. So while Migration Hub does not automate the steps of the migration, it does provide a single place for you to track the progress of the applications you are migrating.
In phase 2 of preparing for your migration, the focus is on discovery and planning. As a consultant, I frequently had the task of combing through a company's environment to try and track down all of the in-use software and to create spreadsheets of which servers ran which services. The AWS Application Discovery Service helps you to plan your migration to the AWS cloud by collecting usage and configuration data about your on-premises servers. Application Discovery Service offers 2 ways of performing discovery and collecting data about your on-premises servers: agentless and agent-based. Agentless discovery works with VMware vCenter and can be performed by deploying the AWS Agentless Discovery Virtual Appliance. After the Discovery connector is configured, it identifies virtual machines and hosts associated with vCenter. The Discovery connector collects configuration information about your servers, like server host names, IP addresses, MAC addresses, and disk resource allocations. The Discovery connector also collects metrics about the VMs. These data points can be extremely useful in your migration planning activities, especially if you are using the re-platform approach. It can inform decisions like what type and size of EC2 instance to use. Knowing both the average and peak utilization metrics for things like CPU, RAM, and disk I/O, you can make a more informed decision about how to design your environment in AWS. It's important to note, however, Discovery Connector cannot look inside each of the VMs, so it cannot figure out what processes are running on each VM or what network connections exist. If you need insights into that type of information, then using an agent-based approach will be required. Agent-based discovery can be performed by deploying the AWS Application Discovery Agent on each of your VMs and physical servers. The agent will then collect static configuration data similar to the Discovery Connector. In addition to those static config details, the agent will record detailed time series systems performance information, inbound and outbound network connections, and processes that are running. You can export this data to perform an analysis and to identify network connections between servers for grouping servers as applications. The Application Discovery Service is integrated with our AWS Migration Hub, which helps to create a single pane of glass view into migration progress. After the service has performed its discovery, you'll be able to view the discovered servers, group them into applications, and then use the Migration Hub to track the migration status of each application. All of the data that is collected by the Application Discovery Service can be exported for analysis using tools like Amazon Athena and Amazon QuickSight. Overall, the AWS Application Discovery Service helps you to obtain a snapshot of your current state of your data center servers, and the data collected helps to create a cost-optimized migration plan based on your unique business requirements.
Hi there, I'm Rick and I'm the architect for this course. I'm here to give you folks a quick introduction to what you're going to be doing in your labs. Now, I have 4 of these for you, so let me give you the scenario so you can play along. We're going to say that you work for a small fashion magazine in New York who happens to use a very popular blogging engine called Ghost for their main website. Now, as it's a relatively small company, you're only one of 2 techs, and you've been volunteered by your boss to help them migrate the website from on-prem to the AWS cloud. Sounds like fun, huh? Well, your boss says he's happy to manage the domain name and can point it to the new migrated cloud version once you're done. And luckily for you, he has also volunteered the other tech to set up the network infrastructure in the cloud, meaning you can just focus on migrating the app itself along with its database. So at this stage, you're not that familiar with what they even have on-prem. All you know is what the other tech told you via instant chat earlier today. He told you that there are 2 boxes. One is an app server running Ghost, and the other is a database server running MySQL. And he thinks they're both running Ubuntu. Real helpful, right? Gotta love all that detail. So, you're going to roll up your sleeves and decide that you're going to break down this migration into a few steps. Naturally, you're going to be doing a dry run here and just experimenting, not actually switching over from the live site. Once you know your best plan of action, however, through experimenting, then you can do the real migration. So here's your current line of thinking. Number 1, find out what you're dealing with, technically, on-prem. Number 2, while keeping the existing site live, use a tried and true method for making a copy of your data and using it to seed the new resources in the cloud. Number 3, you'll do it again, i.e. run another experiment. This time trying a different method to see if one way is maybe better than another. And finally 4, you're going to research and experiment with AWS tools and services that you think can assist you in migrating your app. And you figure by going through this journey, you'll come out the other side with a really solid perspective on what needs to be done and can help your boss migrate in the best way possible. Sound like a plan? So your first goal, Lab 1, will be to poke around the existing on-prem network and discover exactly what you're going to be working with. Now, as this is just a lab, we obviously don't have a real on-prem system for you to migrate from, nor a real domain name. What we have done is set up a system in an AWS region, specifically US West 2, and we can pretend that this is your on-prem network. We have also set a network up in another AWS region, US East 1, which will act as the eventual cloud target network. And luckily, your work colleague has already set that up for you. This means all you have to focus on is experimenting with app and database migration. Get the idea? Okay, so now we know the scenario, and I've given you the 30,000-foot view of the labs. Join me in the next video where I'll briefly cover what you'll be doing in Lab 1. Okay, see you all soon. So I mentioned it in my previous video, the purpose of this lab is to discover what you're about to migrate. As a reminder, your on-prem is actually an AWS region, US West 2, and at this stage you know very little about the application. You only know that you have 2 servers running Ubuntu, one for the Ghost app and one for MySQL. Your work colleague was pretty light on the detail there. But you know, that's okay, because you're going to find out everything you need to know during this lab. This is what we call the discovery process. You can almost think of yourselves as detectives poking around the system to get the facts. So what are you going to need to do first? Well, I'll have you log into both machines and install a discovery agent on each one. And that way you can start collecting some facts or data. Then I'll have you poke around the servers for a bit and find out what each app is actually doing, how the machines are set up to talk to each other, that kind of thing. And I'll get you making notes of any configuration settings. You'll then look at all that information and aggregate all your findings to help you understand what and how to migrate. You will be trying various migration options in later labs, but for now, I just want you focused on getting an agent on those machines and have you poke around there, playing detective. Don't worry, you're not going to need to do any coding. These labs are mostly, press this, read that, type this, etc. It should be pretty easy for you to get through most of the steps. I just want you to pay close attention to all the lab instructions. And if you get stuck or something just isn't working, head over to the forums and seek help from either us or your peers. Okay, I'm out of here. Good luck, and I'll see you soon.
While this isn't a security-specific course, security should always be considered. Whether you're building a multi-tier, globally accessed application, or you're discussing migration of your environments like we are here, security needs to always have a place in the conversation. With the migration discussion, our talking points aren't different from many of the topics that would normally be covered. Our focuses will likely be things you've heard before, as we'll be talking about protecting your data in transit, protecting your data at rest, and protecting access to your data for use. And while these may not be new topics, it is important to understand them in the context of a multi-environment communication. When securing data in transit, our goal is to make sure we can communicate easily between environments while protecting the data. This is where you try to reduce the risk of unauthorized exposure by defining and enforcing requirements and implementing controls. You definitely want to make sure you have defined data protection in transit requirements and encryption standards based on data classification to meet your organizational, legal, and compliance requirements. Also, enforce your defined encryption standards to ensure that meeting these requirements is not optional. Additionally, ensuring that there are tools and controls in place to help you with enforcement of your standards will go a long way towards helping you stay secure in transit. The first and one of the easiest things you can do is just to use authenticated network communication protocols. Using IPsec tunnels and transport layer security, or TLS, to encrypt in transit will go a long way to reduce the risk of data tampering or loss. Additionally, setting up automated tools to help identify when other issues or risks become apparent can also be very helpful. Using a tool or detection mechanism to automatically detect attempts to move data outside of defined environment boundaries can be very helpful in identifying any threats to your security and help prevent data exposure. With data at rest, encryption is really the biggest point here. You will really want to make sure you have established and enforced encryption methods in place for everywhere data is held in your environments. In addition to this, your key management solutions will play a big part in your encryption for your data. depending on the services within AWS and your current environment's resources that you're using, there are several options that you can look into for helping you to maintain data security at rest. For instance, many of the data store services with AWS have options that are simple to implement where you essentially turn on encryption for that service. For your current environment, if you are not already using an encryption key management solution, it will be important to evaluate and find a solution as soon as possible. And I know it can reduce the level of desired performance depending on the resources or AWS services you're using when you start to implement encryption mechanisms. But that is why it's important to have these conversations early on so that any additional performance overhead encountered by your security measures can be considered for your migration expectations. When it comes to securing your data use while migrating, we're focusing on general data access and permissions. As with other areas of access control and permissions that we usually talk about with AWS, using a least privilege access model is going to be a great mindset to keep. Users and applications should only have access to the specific data they need, should be given access for only when they need it, and should only be able to access how you want them to access it. Depending on the data store options you have available to you, the level of granularity you're able to provide in terms of what each user can access will vary. It's just important to take the extra work to make sure that no one has access to more than they should, or at least that they only have access to the appropriately classified data. For limiting when they should have access, using AWS services and automated mechanisms that allow you to limit time users have to access data will become very helpful. Sometimes this can be done in a policy. Other times, you need to look at automation jobs or workers that can open and close connectivity methods to ensure that data is only accessed when necessary. And for limiting how you want users to access, that's where we go back to enforcement of the methods that you established when looking at protecting your data in transit. Making sure only secured connections and protocols are used helps to avoid the accidents that can occur when those become optional instead of required. Well, that's all that I have for you in terms of multi-environment security. I know this was all very broad and theoretical, but a lot of the specifics will depend on what resources, tools, and services you have available to you and what features they provide in terms of security. Make sure you check the course notes for links to provide additional information around securing your environments, and keep thinking about how those concepts can be implemented in your multi-environment setup as you're migrating. I'll see you later.
The tools for migrating data to the AWS cloud are either unmanaged or AWS managed. This illustration displays some options for data migration, depending on the volume of data and the velocity of migration. Unmanaged migration tools are the easy, one-and-done methods to move data at small scales from your site into Amazon Cloud Storage. These include options like rsync or the Amazon S3 and Amazon S3 Glacier command line interfaces. AWS managed migration tools help you manage the data migration tasks more efficiently and can be further classified into two broad categories: tools that optimize or replace the internet, like Direct Connect, and tools that provide a friendly interface to Amazon S3. If you have large archives of data or data lakes, or in a situation where bandwidth and data volumes are simply too large, you might want to lift and shift the data from its current location straight into AWS. You can do this either by using dedicated network connections to accelerate network transfers, or by physically transferring the data using AWS Snowball. If your data stores can gradually migrate over time, or when new data is coming from many non-cloud sources, consider methods that provide a friendly interface to Amazon S3. These migration services can leverage or complement existing installations, like backup and recovery software or a SAN. Several AWS technology partners and third-party solution providers also offer tools for migrating data to AWS. For a list of vendors who partner with AWS to provide data migration solutions, check out the course notes.
Welcome back, detectives. I trust that after the last Discovery Lab, you have a really good picture of what you'll be migrating, right? Well, let's recap. What do we know so far? Well, we have an EC2 running a Ghost app using an EBS drive, a MySQL database running on the other EC2, again with an EBS drive, and we have our data from the agents that we installed on the machines. We also have some idea about the configuration settings that were used for the Ghost app and MySQL. Now, armed with all this information, the question now is, how do you move it from one place to another? How do you get a copy of your on-prem database in US West 2 over to the cloud in US East 1? And how do you get the static content from your Ghost app over there too? Well, you have options. But what are you going to suggest to your boss? You know, your fashion magazine website can take some downtime, but you have to minimize that. And you think it would probably make sense to provide options rather than present a one-size-fits-all solution. So, as you want to try different methods of migration, you figure you'll start off with the most obvious one, a simple SQL dump and a restore, along with the EBS snapshot for the app data. Here are the steps I'll have you take. Number 1, you'll use a MySQL dump to make a copy of your on-prem database data and pop it in S3. Number 2, you'll take an EBS snapshot of your Ghost static content, which can again be stored in S3. 3, you'll create a Ghost app server in US East 1 and seed a new EBS drive with that snapshot. And 4, you'll create a MySQL database and seed it using a restore. And that's about it for this lab. Best of luck, and hopefully by the time you're done with this lab, you'll have a working version of your on-prem fashion website running in the cloud.
Welcome to week 3. This week, we're going to be focusing on services within AWS that can help us with our migration. We'll be looking at topics around data transfer, storage, databases, and some other things that will hopefully help you to make the most out of moving to AWS. Keep diving through those readings and notes and keep learning. I'll be back on your screen before you know it. When moving from an environment where you have limited storage solutions, it's nice to know that you have flexibility to find the best solutions to use when concerning your storage choices in AWS. For this session, we'll quickly review 3 of the most commonly used storage solutions available for you. Starting with the most commonly used and default block storage mechanism in AWS, Amazon Elastic Block Store, or EBS. This provides block-level storage volumes for use specifically with EC2 instances. EBS volumes behave like raw, unformatted block devices that you can mount as devices to your instances. And while you can mount multiple volumes on the same instance, each volume can only be attached to one instance at a time. You can create a file system on top of these volumes or use them in any way you would use a block device, such as a hard drive. Additionally, you can dynamically change the configuration of a volume attached to an instance. Within EBS, there are several configurations open to you, and the volume types that you can choose include both SSD and traditional HDD options. The general purpose volume is the most common type and the default volume used by Amazon EC2. General purpose SSD volumes provide strong levels of performance for a wide variety of workloads. The Provision IOPS SSD, or PIOPS volumes, offer you some of the highest performance SSD volumes for mission-critical low latency or high throughput workloads. You also have the ability to adjust the level of performance you may require. These are best utilized when you need consistent and high levels of performance. For our HDD volumes, we have another 2 options for you to consider. For the throughput optimized volumes, these are for frequently accessed, throughput-intensive workloads. While it's not the fastest type of storage in EBS, it is a great balance of cost and functionality. The other type of HDD EBS volume is the cold HDD volume. These are going to be best suited for scenarios where the lowest cost block storage is of utmost importance. The major difference between throughput optimized and cold HDD is, unsurprisingly enough, the throughput. Both are designed to be cost-effective options. If you're planning a higher throughput need, but still with lower overall I/O per volume, then the throughput optimized would be the way to go. If, on the other hand, you need a higher I/O on the volumes, the SSD options are still going to be better choices. So that's about EBS. But the title of this video also mentions that we'll be talking about Amazon Elastic File System. So where is it? Well, lucky for you, that's my next topic on this video. Elastic File System, also known as EFS, allows you to create a file system, mount the file system on EC2 instances, and then read and write data to and from your file system. And while that may sound strikingly familiar to what we just covered, it does. There are some major differences though. First off, EFS can be mounted to multiple EC2 instances at the same time. This enables you to have a shared file system for multiple servers. Secondly, EFS is just that, a shared file system. EFS is a file storage system that uses NSF v4 and currently supports versions 4.0 and 4.1, though we do recommend that you use the most recent version. EFS does provide another difference that you can utilize, and this becomes incredibly important while running multi-environment workloads, like when migrating. That other difference is that your AWS housed EFS can be mounted to by on-premise servers. So now that we've looked at EBS and EFS, let's take a look at our last topic for this section, Amazon Simple Storage Service, also known as S3. S3 is an object storage system that was intentionally built with a minimal feature set that focuses on simplicity and robustness. To use S3, all you do is create a bucket, which is a container for your objects, and then start loading in the objects. The objects are fundamental entities stored in S3, which consist of the object data and metadata. While the object's data is opaque to S3, the metadata is a set of name-value pairs that describe the object. In S3, once you've created the bucket, you can work with objects either through API or directly through the console. Though S3 is a natively internet-based service, meaning that access is provided through internet-accessible endpoints, it does not mean that there is any loss or compromise on how secure your data is. Through access control lists, bucket policies, encryption options, and additional security features, you have full and granular control on how you grant access to objects in your buckets. In terms of migration, S3 is unique in that it can be used not only to store objects for your applications to utilize after migration, but can also be a great location to store images, backups, database dumps, and other components that are used while migrating. So while you're planning out your migration, be thinking about what the best storage option for your various workloads might be. Test and experiment with them and find out what provides the most optimal performance to meet your needs.
Migrating your workloads doesn't just involve moving around virtual machines. It likely also involves moving large amounts of data. Sure, copying a couple gigabytes of data to the cloud wouldn't take that long, but what if you've got several hundred terabytes of data? Even if you're lucky enough to have a high-speed internet connection, it will still take days, if not weeks, to upload. Let's do some quick math. Let's say you've got 80 terabytes of data that needs to be moved, and you've got a 1 gigabit connection to the internet. The business has decided that we're allowed to use the entirety of the connection for the duration of our transfer. So, how long are we looking at? Well, a terabyte is about 1,000 gigabytes, so we've got 80,000 gigs to copy. A 1 gigabit connection is being measured in bits, not bytes, so we've got to divide by 8, leaving us with 0.125 gigabytes per second of upload. So 80,000 divided by 0.125, divided by 60 seconds in a minute, divided by 60 minutes in an hour, divided by 24 hours in a day, carry the 1, it looks like we'll be done in just over a week. Your business can go a week without internet, right? Assuming a week of downtime isn't going to fly with management, we can look into other options for migrating the data. AWS Snowball is a physical device that can be connected directly to your network in the data center and leverage the local network to copy the data. The AWS Snowball device can currently hold up to 80 terabytes and is protected by AWS Key Management Service to encrypt the data. Using Snowball, you can import and export data between your on-premises data storage locations and Amazon S3. The Snowball is its own shipping container, and its e-ink display changes to show your shipping label when Snowball's ready to ship. But what if you have a lot of data to move? Not gigabytes or terabytes or even petabytes, but exabytes of data. Well, we've got a moving truck for that. Literally, a semi-truck. Well, technically it's the shipping container on the back of the truck, but it's called AWS Snowmobile. And this storage on wheels service holds up to 100 petabytes of data. Check out the notes on this video for a link to the launch announcement and more information. Moving data is the real bulk of the work for a migration. It's important to make sure it's done efficiently and securely. Depending on how much data you need to move, AWS Snowball could be the right choice.
There are times when, whether during a migration or just wanting to have AWS cloud-backed storage for your on-premises resources, you need to be able to connect across environments. AWS Storage Gateway utilizes a VM image in your on-prem environment that securely connects to the gateway endpoint within AWS. This allows you to connect your local storage resources to the AWS cloud and enables you to add availability, fault tolerance, and scalability to your storage mechanisms. For solutions, Storage Gateway offers file-based, volume-based, and tape-based options. File Gateway, the file-based solution, supports a file interface into Amazon Simple Storage Service, or S3, and it enables you to store and retrieve objects in S3 using industry-standard file protocols such as Network File System, NFS, and Server Message Block, or SMB. A Volume Gateway provides cloud-backed storage volumes that you can mount as iSCSI devices from your on-premises application servers. With this volume-based solution, you do have two configuration options. There are cached volumes and stored volumes. Cached volumes allows you to store your data in S3 and retain a copy of frequently accessed data subsets locally. Stored volumes can be a solution for when you need low latency access to the entire data set. All of the data is stored locally, and snapshots can be made from the on-prem storage and used to either recover local volumes or create volumes inside of your AWS accounts. Moving on, the last type of gateway I want to mention is the tape gateway. With a tape gateway, you can durably archive backup data into AWS. A tape gateway provides a virtual tape infrastructure that scales seamlessly with your business needs and eliminates the operational burden of provisioning, scaling, and maintaining a physical tape infrastructure. Another tool that can assist when you're working between environments, like when migrating or transitioning to a hybrid environment, is AWS Data Sync. Data Sync is a data transfer service that simplifies, automates, and accelerates moving and replicating data between on-prem storage systems and AWS storage services over the internet or AWS Direct Connect. Currently, Data Sync supports transfers between NFS to Amazon Elastic File System or Amazon Simple Storage Service. This may sound somewhat similar to Storage Gateway, but the major differences are that Data Sync primarily is utilized to transfer from an NFS source, and the destination can be EFS. Similar to Storage Gateway, Data Sync uses an agent, which is a virtual machine that is used to read or write data from on-prem storage systems. The agent is currently deployed on a VMware ESXi hypervisor, and you use Data Sync Management Console or the API to set up and activate your agent. With these tools, hopefully you have some additional ideas of how you can manage data transfer and access across environments. The course notes will have more on Storage Gateway, Data Sync, and their options. I encourage you to take a look. As we mentioned earlier in the course, migrating your databases can be a very difficult task. Outside of all of the planning and analysis, you have to set up the necessary network connections, find a time that works for adding the additional load to your active DB, take a backup of all of the necessary data in your database, and enable for updates to the database to be replicated to the new environment. And you have to do this without negatively affecting your running application and ensuring the security and integrity of the data. When working with AWS, there is a service that, while it won't completely remove the work needed to migrate between database environments, it will help to lighten the load. AWS Database Migration Service, or DMS, is a tool that makes it easier to migrate relational databases, data warehouses, NoSQL databases, and other types of data stores. You can use it to migrate your data into the AWS cloud, between on-prem instances, or between a combination of cloud and on-premises setups. Whether performing one-time migrations or ongoing replications to keep environments in sync, DMS can help you with the managing of the tasks. Also, if you need to perform a schema change while migrating, there is an accompanying tool with DMS called AWS Schema Conversion Tool, which supports converting your existing database schema from one database engine to another. To perform a migration, DMS connects to the source data store, reads the source data, and formats the data for consumption by the target data store, where it can then load the data into the target. DMS also provides the ability to monitor the migration so that you can keep an eye on everything happening. We'll be going into more detail with DMS and the schema conversion tool later, but that should provide you a good starting point. Until next time.
So far, we've covered how to migrate servers and data to the cloud. And now I'd like to talk about database migrations. It should come as no surprise that AWS has a service aimed squarely at helping you to perform this task. It's called the AWS Database Migration Service, or DMS. You can use DMS to migrate your data to and from most widely used commercial and open source databases. The service supports migrations to and from the same database engine, like Oracle to Oracle, and also migrations between different database platforms, such as Oracle to MySQL, or MySQL to Amazon Aurora. You can also use DMS to migrate your on-premises database to a database running on Amazon EC2 instances. DMS can be configured to perform an ongoing replication, which can allow you to migrate databases with zero downtime. AWS Database Migration Service also provides a schema conversion tool, which we'll cover more in depth later, to help convert stored procedures in Oracle and SQL Server to equivalent code in the Amazon Aurora MySQL dialect of SQL. When a piece of code cannot automatically be converted to the target language, DMS will clearly document all locations that require manual input from the application developer. You can use AWS Database Migration Service for both one-time data migration into RDS and EC2-based databases, and also for continuous data replication. DMS will capture changes on the source database and apply them in a transactional, consistent way to the target. Continuous replication can be done from your data center to the databases in AWS, or in the reverse, replicating to a database in your data center from a database in AWS. Just a quick note, to use AWS DMS, one endpoint must always be located in an AWS service. Migration from an on-premises database to another on-premises database is not supported. We'll be taking a look at DMS in this week's lab. During the video on the Database Migration Service, I mentioned a very powerful tool called the Schema Conversion Tool. This tool allows you to take an existing database and convert its schema to a different engine. I thought it would be helpful to show you a quick example use case of the tool in action, and show you the report it can generate. For this example, I've set up an EC2 instance running SQL Server. This will also be the server that I run the tool and do the demo from. What we're looking at is that server. We're going to pretend that this is our on-premises SQL Server for the demo. Since we're on the machine, let's take a look at what we'll be converting. I've loaded up a sample database called Bike Stores.
We can take a look at the database, and we see that there are multiple tables that we'll need to convert. If we do a quick query on one of the tables, we can see that there are several columns and rows of data that will need to be converted. Looks like we have about 1,400 customers listed in the table. Before we're able to start converting, we'll need to set up our destination database. Since we want to make full use of AWS, I'll be converting to an Amazon Aurora MySQL compatible database. In the AWS Management Console, we'll jump over to the Relational Database Service, RDS. We'll click Create Database, and since Aurora is the default option, we just need to change a few items. We'll name the database SCT Target, and the rest can be left at defaults. Now we can create the database. We can see in the console that our database is currently creating. After a few minutes, it will show as available, and we can continue. Now we'll move over to the schema conversion tool, which I've already installed. We'll need to create a new migration project. I'll leave the default name and location. Under the engine type, we'll select SQL Server, and after clicking Next, the tool will analyze the database to find available schemas. We'll select our Bike Stores database, click Next, and the tool will begin to analyze the database. Once the analysis is complete, a summary report is generated, which tells us how much of the data that SCT will be able to convert. We'll come back to this data in a few moments. To configure our target, we need some information from our newly created database instance, specifically the endpoint address, which we'll enter in the server name field. Once we fill in the rest of the fields, we can test the connection, then proceed once successful. After clicking Finish, we're shown the Schema Conversion Tool project page. To get a nice assessment report, we can go to the View, Assessment Report view. On this page, we see that SCT will be able to convert 100% of our database objects. I've also created a database, AdventureWorks, that SCT has identified some issues with. Let's take a look at the assessment report to see what actions it recommends. We can see under the Action Items tab that there are several issues listed. If we drill down into one of the specific examples, we can see the code that currently exists in the SQL database and the tool's recommendation to perform a manual conversion. Depending on your database, you may or may not run into conversion issues like this. That's a quick look at the assessment capabilities of the Schema Conversion tool. The tool can be used in conjunction with the Database Migration Service to convert your database schemas and to migrate objects to a new target. I've added links in the course notes for additional reading.
While we're talking about data store options, it's important to bring up Amazon Aurora. Aurora is a MySQL and PostgreSQL compatible database engine offering within Amazon Relational Database Service, known as RDS. Aurora is designed to provide multiple times the throughput of traditionally available database engines, but without having to make drastic changes in how your applications access your data. It is a fully managed and distributed system that is able to meet the higher levels of performance by utilizing an SSD-backed virtualized storage layer specifically built for database workloads. Additionally, Aurora's storage is fault-tolerant and self-healing. Disk failures are repaired in the background without loss of database availability. Amazon Aurora Serverless, which is a configuration that can be used for Aurora, is an auto-scaling solution where the database will automatically start up, shut down, and scale capacity up or down based on your application's needs. It enables you to run your database without the difficult task of database capacity management. In the context of migration, especially when you start looking for how you can optimize your application's performance in the cloud, solutions like Aurora and Aurora Serverless can be very helpful. Aurora allows you to manage using the DB class sizes, and reads can be scaled out by distributing requests across the read replicas. If the workload changes, the DB class size and number of replicas can be adjusted to meet the changes in demand. While this is a functionality that exists, it's best suited towards predictable workloads. With Aurora Serverless, you can create a database endpoint without specifying the DB instance class size. Instead, you set the minimum and maximum capacity. The database endpoint connects to a proxy fleet that routes the workload to the fleet of resources that are automatically scaled. Database client applications don't need to change to use the proxy fleet. Aurora Serverless manages the connections automatically. The reason that the scaling is so rapid is because it uses a pool of warm resources that are always ready to service requests. I highly recommend that you look further into Aurora and Aurora Serverless to see if they possibly fit your optimization needs when migrating. The course notes will guide you to the documentation for these options, and I'll talk to you later.
During a migration, there will come a time when you need to connect your network to AWS. Depending on your migration, you might even be running in a hybrid scenario, systems both on premises and in AWS. Beginning with the discovery phase, we'll have a need for agents to report their findings back to AWS. During the migration, we'll need to be able to transfer data like our virtual machines, storage volumes, and databases. After the migration, we'll need to be able to perform tasks like monitoring, ongoing replication, and potentially additional data transfers. AWS services are delivered over the internet. For many actions and activities, we can simply use the AWS Management Console or AWS Service APIs, which only require an internet connection to access. Many administrative tasks can be accomplished in the Management Console. When we start getting into automation and tools, which Seth will talk more about, we begin to get away from the Management Console and begin interacting with AWS APIs. However, when we want to talk with our own resources running inside of AWS, there are very few occasions when we would want to make those connections or perform those tasks over the open internet. I wanted to quickly cover two options that we have to securely make the connection from your on-premises network to your virtual private cloud and AWS services. The first option is one that many people will be familiar with, VPN over the internet. There are several options for creating and configuring a VPN connection, and we're not going to dive into that in this course. The important part for our migration is to understand that this connection establishes a secure tunnel or link from your network to AWS. With the right configuration, the resources that you have running in AWS can be seen as an extension of your on-premise network. In this example, we're still using our internet connection to talk with AWS and our resources in AWS, but the VPN tunnel allows for that communication to happen securely. If your migration or operational requirements need dedicated bandwidth to talk to AWS, or you have a requirement to not use the open internet for communication, there's AWS Direct Connect. Direct Connect links your internal network to a Direct Connect location over a standard 1 gigabit or 10 gigabit Ethernet fiber optic cable. With this connection in place, you can create virtual interfaces directly to the AWS cloud, for example to Amazon EC2 and Amazon S3, and to Amazon VPC, bypassing the need for public internet in your network path. You can also establish a VPN tunnel over the Direct Connect link, allowing for a secure tunnel of communication from your on-premises resources to the resources in AWS. These connection options can allow for AWS to act as an extension of your network, which enables smoother data transfers, migration cutovers, and ongoing replications. Network design is an important part of your AWS infrastructure. During the migration planning phase, you'll want to ensure you plan for how your systems will talk to each other.
Hi again. So you have now figured out how to migrate a database server and a Ghost app to the cloud. Brilliant. But you think, are there better ways to achieve the same thing? Well, in this lab, you're going to experiment with that idea. Specifically, I'm going to have you leverage AWS Database Migration Service. You won't have to remigrate the app server, you can leave that there. Instead, I'll just have you focus on migrating the database. Yes, again. But this time, the approach will be pretty similar to the last one. However, in this lab, we're going to have you experiment a bit. Well, why not, right? I'm going to have you re-platform over to Amazon Aurora. After completing this lab, you will see the advantages in using AWS Database Migration Service versus the previous approach. You ready? Okay, have fun.
All right, so let's say theoretically you're up and running in AWS. You've taken the time to plan, evaluate, and move the necessary components over. You've tested the applications and are pretty sure they're going to be okay. Now that it's all running, how are you going to do the actual cutover? Can you afford any downtime? Is there a risk of data loss? What do you do if you experience any errors that you weren't expecting? As with all of the other questions we've presented in this course, these are important to ask early and to have a plan in place long before it's needed. So let's talk about two main deployment or cutover methods. The first one is called red-black. In the red-black method, you have your original environment, you have the new environment, and they're both running. You've set up the records and DNS for both endpoints, and data is being replicated across the environments. Once everything is ready to go, you simply switch the DNS over to the new environment. There, you're done. Well, sort of. In this method, you still keep the original environment running, and if you experience any issues with the migrated application, you can cut back to the original. The next method, commonly referred to as blue-green, is very similar. Setup is the exact same, with both environments being up, tested, and running, and DNS setup is still there. The big difference here is that your cutover needs to be more gradual. With this setup, instead of an instant cutover, you're only shifting a small percentage of traffic at a time. Maybe 5%, maybe 10%, it's up to you how you want to manage it. The major reason for this is to avoid downtime. In red-black, if you have an issue once traffic has been shifted, the application could be down until you're able to move traffic back to the original environment, which could negatively impact any users of the application. With blue-green, issues are less widespread, and the number of affected users due to an issue is easier to manage. Though that doesn't mean blue-green is without its limitations. One of those limitations is that in order to do a blue-green deployment, you have to be using a DNS service that gives you the ability to control the amount of traffic going to each endpoint. While Amazon Route 53 does have this capability, not all DNS services do. Another limitation of blue-green is that this method requires a lot more management. Shifting the traffic over little by little can require some manual effort, which may not be wanted. Outside of that, there is a major consideration to keep in mind for both of these methods, and that is, you need to have monitoring in place to evaluate if any issues are encountered. If you aren't able to identify that errors are occurring, then it's difficult to know whether you need to move back to the original environment or not. Well, that's it for now. Keep these deployment methods in mind and make sure you're evaluating which is best for the specific application you'll be migrating. Week 1 was about understanding migration. Week 2 was about planning and knowing your current environment. And in week 3, we looked at some services that can help you with your migration. Now that we're in week 4, we're going to specifically cover topics around the act of migrating your applications. This week, make sure you're continually going through the notes and readings, and good luck completing the course. Cheers. AWS is API-centric. Hopefully you find that news relieving. Over the past few weeks, we've been looking at a lot of the tools that AWS has that help with merging environments when migrating. But if you had to work with those tools manually, one by one, only through a management console, it would likely drive you crazy. So, to make life easier, AWS is API-centric. What I mean by this is that a large majority of AWS services and tools have directly accessible APIs that you can use for creating, configuring, and managing the services you employ. The reason I bring this up is because especially when you're trying to handle the very difficult and sensitive task of migrating data and applications across environments, handling everything manually is going to cause a lot of headache, a lot of troubleshooting, and timing is going to be very difficult to predict and test on a large scale. If, on the other hand, you're able to automate many of the tasks, the scale of what you can do grows exponentially. Essentially, it goes from a mad scientist running around flipping all of the levers and switches to a better equipped mad scientist monitoring what's going on while their assistants are able to handle all of the tasks. To access the APIs within AWS, there are a couple of options. One, you can use the various SDKs that provide access to the interfaces. And two, you can use the AWS Command Line Interface, or CLI. Both of these give you direct access that allows you to fine-tune and test what you need to do and takes away a lot of the manual effort that you would otherwise have to deal with. The power of these are that they allow you to create scripts and applications to handle a lot of the work, not only during migration, but also when managing, optimizing, and configuring your environment post-migration. It is very important that using the APIs becomes habit as soon as possible. If you're not already familiar, I highly suggest you start with the AWS CLI. This is a toolset that is easy to install locally and gives you the ability to do anything you would be able to do in the management console and more. Try out different tasks, test your various scripts, and see how it can help you. Continuing on with the discussion about automation, there are some additional tools that should be reviewed. Here, we're going to look at AWS Systems Manager and AWS CloudFormation. CloudFormation, which many of you are already familiar with, is an infrastructure and configuration automation tool that enables codified infrastructure. CloudFormation gives you the ability to have one or more templates that can be used to create, configure, and update your infrastructure through the CloudFormation engine. This becomes very helpful in migrating because it gives you the ability to quickly spin up test environments that will look exactly like your production environment. You can test configurations, spin up the full environment with a few clicks or a single command, and then tear it down once you've gotten the data you're looking for. The biggest learning curve with CloudFormation comes in creating templates, but luckily for you, there's a lot of documentation and reference material on this, as well as various tools that can help you put a template together from either sample templates or from scratch. Moving on, with AWS Systems Manager, you have a way to do exactly as the name suggests. You are managing your systems. Systems Manager gives you a path into the servers you are running that enables you to run commands, schedule updates, and manage various other tasks from a single point. When managing a fleet of servers, the ability to run a command on the entire fleet without having to directly connect to any of the servers individually saves time and effort. Another major benefit of this is that it allows you to manage systems not just in AWS, but also with your on-premises servers. It has this ability because it uses an agent, the Systems Manager agent or SSM agent, that can be installed on both Amazon EC2 instances as well as your servers running locally. As long as they have some connectivity to AWS, you can have a single access point to manage cross-environment fleets. These tools are just some of the additional options you have when it comes to automating tasks that can aid in migration. The notes have some links that will further share some of the features that they provide, as well as ways to get started. I highly suggest you take a look. Over these few weeks, we have looked at how important planning is when it comes to migrating, brought up important questions when evaluating both where you are and where you're wanting to go, and looked at a lot of tools that can help with your migration. Now, I want to talk about one of the solutions that helps you with everything as opposed to just one aspect of the migration. TSO Logic is a solution that exists within AWS to provide insight into what you currently have and give you options into what you may want to utilize in AWS. This can be done as a pre-migration step or as an ongoing analysis to ensure that you are always running each application in the best place with the right software, even as your environment and prices change. TSO Logic provides discovery of your existing resources to help identify what you are running in your compute, storage, database, and other areas to help evaluate what your total cost of ownership, or TCO, is for various applications. We then are able to use predictive analytics to help determine the best fit for your workloads in the cloud. Using data-driven methodology and continuous visibility will help to provide ongoing insights and predictive analytics for all of your workloads. TSO Logic, as well as many other tools, can help you with both specific parts of your environment as well as full migration assistance. I highly recommend looking at what options you have and finding what will help to make your migration as easy as possible. Another tool in the toolbox to help you with migrating is called Cloud Endure. It's actually a little misleading to call Cloud Endure a tool. It's more of a fine-tuned machine that enables a much easier end-to-end migration into AWS. Cloud Endure migration simplifies, expedites, and automates large-scale migrations from physical, virtual, and cloud-based infrastructure to AWS. It automatically converts any application running on supported operating systems, enabling full functionality on AWS without compatibility issues. Continuous data replication takes place in the background, without application disruption or performance impact, which ensures that data is synced in real time and minimizes cutover windows. When migration cutover is initiated, Cloud Endure executes a highly automated machine conversion and orchestration process, allowing even the most complex applications and databases to run natively in AWS. The continuous data protection engine works in memory, neither taking snapshots nor writing any data to disk, which means near zero impact on performance. Furthermore, Cloud Endure is designed for large-scale migrations and enables the replication of data from thousands of machines simultaneously without performance impact. After initial replication, you can spin up all of your machines in parallel as well as execute any post-migration scripts at scale as necessary. You can also manage the entire migration lifecycle and verify your readiness for cutover directly from the Cloud Endure console. Lastly, Cloud Endure gives you the control to test your target machines as often as you like in preparation for cutover by just clicking a button. It also provides you with the ability to quickly and easily shift your environment to AWS from existing physical or virtual data centers, private clouds, or other public clouds. As you can see, while you can work on migrating your environments yourself, using the tools and creating your own applications and automation scripts to handle your environment transfer, tools like Cloud Endure can help to make the whole ordeal much easier. The notes will have further information on Cloud Endure. Make sure you review them to see if this might be a good solution for you.
Okay, great. You made it all the way through to the final week's lab. Congratulations. Let's recap on what you now know. You know how to move an application from on-prem to the cloud, how to move a database from on-prem to the cloud in a conventional way, and how to use AWS Database Migration Service. You even know how to prepare an environment for Aurora and move a MySQL database over to it. So you're probably thinking, What do I have in store for you in this final lab? Well, I'm going to have you migrate all over again. I know you're probably hating me right now, but this time you'll be leveraging a cool new AWS service called Cloud Endure. Cloud Endure helps you automate and standardize your migration in many ways, and you'll see that as you progress through this final lab. Now, it's not 100% automated. You don't just push a button and throw some fairy dust on it and it's all magically migrated. But it is going to help you with some of what I like to call, the grunt work. So yes, you're going to start over from scratch, but with Cloud Endure by your side, you will be fine. This lab will walk you through all the steps necessary to do your app migration using the AWS console. Specifically, you'll be using the new Cloud Endure console. And by the time you complete this final lab, you should have a good grasp on app migration methodologies and which tools you could use to help you, such as DMS and Cloud Endure. Okay, I think I'll say my goodbyes here, as I know that you folks will have no trouble completing this final lab successfully. So I'm going to leave you in the capable hands of the rest of the team. Best of luck, enjoy this last lab, and I'll see you all on the next class. Rick out.
As we've seen over the last few weeks, there are a number of tasks that you'll need to perform in order to plan, prepare, and perform your migration. The good news is you don't have to do it alone. The AWS Migration Acceleration Program, MAP, is designed to help enterprises that are committed to a migration journey. MAP was created to provide consulting, support, training, and service credits. The goal is to reduce any associated risks with migrating to the cloud, to build a strong foundation for the operation, and to help offset the initial costs. The program includes guidance and methodologies for migrating legacy systems, as well as a suite of automation tools to help speed up more common migration scenarios. AWS also maintains a partner competency program, which allows companies in our partner network to demonstrate and prove their expertise in areas like migrations. Successful completion of a migration can be aided by leveraging the knowledge and/or tools of migration partner solutions. There are several different types of partners that can assist with your migration. Migration delivery partners are able to help with every stage of a migration, including getting hands-on. Migration consulting partners provide expertise and training to help enterprises quickly develop specific capabilities or achieve specific outcomes. Migration technology partners provide the tooling and automation to help with all phases of a migration, from discovery to workload migration to data migration. A migration isn't likely to be something that you tackle completely on your own. When it comes to migrations, the best approach is to leverage all the tools and experience at your disposal.
As we're drawing to a close for our course on migration, I wanted to take a moment to quickly review the application migration types. What we covered in this course were, as we frequently call them, the 6 R's. They consist of rehost, replatform, repurchase, refactor, retire, and retain. Starting with retain, this focuses on identifying components that are either not ready or not necessary to migrate. Oftentimes, when retaining will be used, it is important to consider if and how your migrated infrastructure and your retained infrastructures will need to communicate, and set up the appropriate and secure channels to do so. With retire, you still need to identify what components may not need to be migrated, but for the purpose of evaluating what will not be needed by both the migrated environments as well as any retained components. Once the evaluation is completed, the unnecessary pieces are eliminated and the applicable components are migrated. With refactoring, also seen as re-architecting, you look not only at what needs to be migrated, but also at how that particular application might be re-architected to better utilize the advantages provided by the AWS cloud. Shifting from a traditional architecture to a service-oriented architecture, for example, could be one way that you refactor your application to move into the cloud. Now, repurchase, replatform, and rehost are all very similar, but of course have their minor differences. With rehost, you are looking at as close as a one-to-one migration as possible. In this case, you are looking to move quickly with minimal changes. With replatform, you're still looking at a similar move, but also considering what might provide a small and easy optimization to your performance or usability. For example, replacing a server running a database engine with an Amazon Relational Database Service instance. This could make your database usage a bit easier while maintaining or improving performance. And with repurchase, you are looking at places like the AWS Marketplace for ready-to-run services configured for the cloud that will get you features that you're looking for without requiring you to custom build a solution. Something that might fit into this category would be purchasing a firewall from the AWS Marketplace instead of trying to import or configure your own on an Amazon EC2 instance. Over the course of the class, we focused on rehost and replatform, but it is important that you look into all of these options for your possible utilization. The last thing I want to say about these is that it is very important that you look at your application's specific needs to find the method that will work for the various use cases you will encounter. Trying to force a single method for all of your migrations will bring about a lot more problems than solutions. Individually evaluate, make your plans, test your plans, and then reformat the plan if necessary. As we stated earlier, the more effort you put forth on the front end of your migration with evaluation and planning, the easier the actual work will be. We've spent the past several weeks talking about the importance of planning and analyzing your migration, looking at services that can help during different phases of your migration, and even briefly discussed some of the AWS tools and partners that can help with the full migration. That final topic is where I want to focus in this video. When migrating large enterprise applications, in all reality, it's going to be better to utilize a third party for your migration. One of the reasons for this is simply the level of knowledge needed. It's a lot to ask of people internally tasked with migration to become experts in all of the services they're going to be using. The steep learning curve to go from novice to expert can be overwhelming and mistakes are easily made. With AWS partners, they have built the knowledge up over years of experience working with and helping other customers migrate to AWS. And that brings us to another reason: experience. AWS partners aren't working on their first migration, but have been doing migrations and consulting for a while. They have been hands-on, have seen a wide variety of scenarios and use cases, and can offer solid advice with other questions you may have around migrating your applications. And lastly, AWS partners often help to provide faster migration timelines than would be possible if you had to learn, evaluate, and test the services while also trying to analyze your infrastructure and plan your migration needs and steps. When it comes to crucial or large applications and environments, we highly recommend looking to an AWS partner to help. It is still important for you to learn about what they are doing and the services involved in order to be able to ask the right questions and easily get going once migrated. But the partners themselves can help greatly with the actual migrations you need to do. The course notes will have a link to our partner page. I highly recommend you look through these to help you identify when you might need a partner, the options you have, and which partners might work best for your needs. Hello everyone. I hope you enjoyed our course about migrating to AWS. Over the past 4 weeks, we looked at topics around defining migration, reviewed migration methods such as the 6 R's, stressed analyzing your environment and needs, urged you to plan your migration, covered some services that are commonly utilized during migration, and looked at actual migration steps. While it was all very conceptual, I hope you were able to take away some concrete actions and ideas for you to use as you plan and evaluate your needs around migration. Keep track of your notes and the links that we provided in order to help you with your continued learning. And good luck with any future migrations you find yourself working with. I'll see you in another class.